Hi, and welcome to today's chemistry lesson. We're dealing with the definition of chemistry and also some of the types of chemistry that you'll see, and finally, different types of research that are involved in chemistry. So this title is this chapter is entitled Matter and Change, and the first section that we're going to look at today is basically defining chemistry as a physical science, meaning it's dealing with things that are in the physical universe. And the definition here that chemistry is the study of the composition, structure, and properties of matter. So how things are built, how they're put together, what they do in certain situations, and also the processes that matter undergoes. So composition, structure, properties, and processes. And when they undergo those processes, how do they change? So we know, for instance, you put liquid water in the freezer, so we reduce its temperature, and water does several things. It obviously gets colder, and it's going to expand. It's going to increase in volume when we put it in the freezer. That's just an example of a process that we'll be studying in chemistry. So this list of branches, there's 6 of them here. It does not include every branch of chemistry, but some of the major ones. We've got organic chemistry, inorganic chemistry, and physical chemistry. And then on the next page, we'll talk about analytical chemistry, biochemistry, and theoretical chemistry. So going back a slide here, organic chemistry. There we go. Organic chemistry is the study. Basically, you want to think carbon when you think organic chemistry. The study of things that contain carbon. So things like medicine would definitely be considered organic chemistry. On the other hand, inorganic chemistry would be just the opposite. Now we're talking about non-organic substances. And actually, this is going to deal with most of the elements on the periodic table. Things like metals, things that don't involve carbon are considered inorganic. So that's a key you're looking for. Does it involve carbon? If so, it's organic. If not, it's inorganic. And there are some gray areas. It's not like a study has to be one of these 6 only. It can go across the border, and maybe you have something that's both organic chemistry and physical chemistry, because physical chemistry is the study of properties and changes of matter in the relation to energy. So like I said with the ice earlier, when you're freezing water, looking at how those changes occur would be physical chemistry. Anytime you're looking and studying the energy transfers involved would be an example of physical chemistry. Next up, we have analytical chemistry. Now this could be take a lot of forms. Basically, think you're analyzing something. You're breaking something down into its components and trying to figure out what it's made of. So you might have somebody studying how much lead is in your water, or if athletes are competing, they might want to make sure they're not taking a performance-enhancing drug. Things like that. Anytime we're looking at how things are composed, we're talking analytical chemistry. Biochemistry is exactly what it sounds like, the study of substances of living things. So we're looking at things like the Krebs cycle that occur on a cellular level, different cell processes that are occurring, like cell respiration. Anything that kind of takes you back to biology class, because you did learn about chemistry in biology, is going to be considered biochemistry. And finally, we have theoretical chemistry, which is less of the physical stuff and more of using models and computers to predict the behavior of compounds that we haven't yet studied. A lot of times it might be too expensive or too difficult to obtain different materials, so we can use theoretical chemistry and the technology we have to model different situations. So what I'd like you to try to do on this Edpuzzle is try to answer some of these questions. I have several multiple choice questions, and that'll be your grade for participation. You don't necessarily have to answer them correctly, but I would like you to try each of them to see if you have a good idea. So the first one, we're looking at what is the branch of chemistry that involves the study of substances and processes occurring in living things. We want to know the branch of chemistry that deals with substances containing carbon. Using mathematical models and computer models to understand a chemical principle would be what? And finally, a team of scientists is working with living cells to determine how a certain enzyme functions within the cells. They're most likely working with which field? So if you want to pause the video and try to answer those, unless you're on the Edpuzzle, in which you can try to select your answer there. I guess we have one more. Two chemistry students are investigating the properties of quartz crystals. They're most likely studying which field? So a chemical is a substance that has a definite composition. So to say something is chemical free, it's hard to imagine anything that would be chemical free because just about everything we can think of has that definite composition. So little mean it's not containing harmful chemicals or something like that. So I have here sugar as an example of a chemical, right? It contains a nice solid structure. Anytime you see sugar, you can pretty much imagine what you're getting. Now, obviously, there's powdered sugar in a different form, or there's granulated sugar. We can grind sugar down to get a different form, but it always has the same elements involved, and it always has the same structure. So can you think of any examples of chemicals? Might have thought of water. Water, as long as it's pure water, is always going to have the same properties. Or maybe even CO2, carbon dioxide. Every carbon dioxide molecule is going to contain an atom of carbon and 2 atoms of oxygen, and always in that ratio. So these are just some examples of chemicals when you hear that word. Now, finally, we want to talk about 2 types of research. And that's something you might not know the end result of your research. You just want to try something out, test it out, and see what comes of it. For instance, the idea of Teflon came about because property to it, they weren't necessarily trying to find something that had these nonstick properties, but they just happened, using the scientific method, they happened to come across it just by studying how materials work. So things like studying why a reaction occurs. You just want to know why it occurs. You're not trying to solve a problem. You're just interested, and you're going to do a study on it. These are all examples of basic research, and I think when we look at applied research, you'll see that this, on the other hand, is when we're trying to solve a problem. So we might want to make things colder, so we're trying to develop new refrigerants. Or, for instance, with COVID-19, the development of a vaccine, the research that was done to do that, there was a specific goal. The scientists wanted to develop a vaccine, so they were doing research on the virus, on things that affected the virus, in order to solve a problem to reach an end goal. So both types of research have their place. We learn a lot about chemistry through basic research, but then applied research can also help us solve a lot of problems. These things often overlap, along with technological development, things like computers, catalytic converters in cars, different biodegradable materials. All these things can improve our quality of life, and they overlap with basic research and applied research. So it's not like one is better than the other or something like that. They all have their place. So that's it for section 1. Hopefully you were able to get into Edpuzzle and answer all the questions. There will be an assignment, homework 1A, due by the end of the week. If you have any questions, feel free to reach out to me.